Okay guys, so up until now we've been doing series and parallel, but today we're going to put them together into a compound circuit.
Parallel of series.
Exactly.
Is that what it's called?
What?
What is it called?
Compound. A
Oh.
compound circuit.
Oh, I thought it was
It's got both. Okay? Now tomorrow we're going to do the whole solving shebang. You're going to the resistance, the voltage drop, and the current through every resistor in the circuit. But today we're just going to focus on finding the total resistance. Because we're going to find out tomorrow that's the first step to solving one. Yes?
So like, this the last one, it's like a series, and then but then it has parallel ones.
Yeah.
Is that a question?
What? Don't. Shh. No swearing. Okay, so first we're going to practice on a series and a parallel. Is this one series or parallel? No one's on this. No, I'm picking cards. Mayra. Is this one a series or a parallel? That's right. How do we find the total resistance of a series circuit, Michael? Your hand is
Yeah,
up.
I'm all up.
You add them all up. That's right.
Thank you.
You just add them together. Okay, so what is 8 plus 4 plus 6?
18.
I hear it, but I don't see it. Hey, Brittany. 18. That's all there is to it.
I thought it was small columns.
Okay. 18 ohms. That's it. Does anybody have any questions about that one? Series tend to be the simplest ones. We like them.
Wait, so would the current be 2? Or would it be a fraction?
It would be a fraction.
You,
Yeah.
right.
Yeah.
Huh?
Okay. Number 2. Is this one series or parallel?
Mine.
She's not here. That's crossed out. Brittany, your card come out. You want to answer again?
And it's the inverse, right? You add the
So
inverse.
she said, what series is it? Like a
Oh.
series or no?
Series or parallel?
Parallel.
Yes. And I'll
I wanted to answer.
you're right for the next one though, but I'm gonna get Daisy. How do you find the total resistance of a parallel circuit?
The inverse?
Yeah, we're gonna add up the inverses. Okay? So the inverse of the total is
A third plus an eight.
third
24.
plus
8. It's 11 over 24.
plus
24.
24.
Why is it the inverse?
Because it's parallel. That's just how we do parallel. We did that one on Wednesday. Were you here Wednesday?
Yeah.
Okay. We did it on Wednesday. Okay. How do we add fractions together? Albert.
You gotta get the
Common denominator.
common denominator.
Yeah. What would be a good common denominator for this problem? Kaylin? No, where's Kaylin? Kaylin. 24. 24 is a great one. Remember, guys, you don't have to use the least common denominator, just some common denominator. Okay? So, if we're going to do 24 as the common denominator, what does the 1/3 become? And I'll take hands for these because I'm getting tired of pulling cards.
8 24.
8 24ths. That's good. What does the 1/8 become? I agree.
324.
3 24ths. And do we have to do anything to that one?
No.
So we just leave it alone.
12 24 is a half.
So that.
Okay.
So
What? How many 24ths is that?
11. 11.
12.
12.
12. All right. Are we done?
No.
What do we gotta do?
Cutting that.
I see a hand.
You gotta put the 12 24s and trade it out with RT.
So
No, flip them.
You flip them.
wait. What do we do? I'm confused.
Or you can just do it easier and just simplify and find
Just
the
flip it.
inverse.
Let's just flip it.
Yeah, that's what I did.
Okay. And what do we got, everybody?
2
Two.
2 ohms. Ohms. Any questions on number 2?
Not really.
I like parallel stuff. I told you guys that, right? It's my favorite. I get excited about parallel strings. Because I'm weird. Okay. Alright, number 3. So this is our compound circuit. It's not a series because I've got choices. There's more than one path. I could go that way, I could go that way. It's not entirely parallel because if I color code it, they don't all go from the same voltage. They don't all have the same voltage drop. It's kind of a combination of both. The best way to deal with these is actually to start with color coding. You don't have to do this, but I've found that it helps a lot. Yes?
Can I just like take like a guess?
Yes,
7?
you're right. Nice guess. So, let's color code first. Remember last week I said to get yourself some sort of crayons or highlighters or color pencils or something?
Yeah.
Remember
We're
this?
both running today.
I said get them for next week. It's Monday, so
Yeah.
if you forgot, that's okay. You can borrow my crayons. They're in the 3rd drawer of that tower thing with the glow on top. You're only gonna need 3 for this problem. But you might as well get like 5 for the whole table or something. Oh, you're gonna pink.
Imagine what you do.
You okay?
Big highlighters.
But they're pretty. Why'd you get pink? I like them.
Yeah, that's just going.
Every always has different colors.
Don't get picky. You just need some colors.
And I usually
Grab 3 different colors.
orange instead of red. It's just so easy.
Wait, what is it? Oh, I don't think I word. It was just I said move Don't ask.
Okay, I won't.
Want a kiss?
Yeah. Thank you.
Oh, she does this thing like. Malaysia me.
No, she doesn't have any that one. I will eat that again. I will eat them when I'm done. I love them. Okay. I love chocolate.
Just Kit Kats.
Kit Kats are awesome. They're so
She comes closer because I can't. Where's your favorite chocolate? Can I have?
All right, does everyone have something colorful?
Malaysia.
Oh,
Since no one said no, we're going on.
Oh.
sorry, what?
Does everyone have something colorful? Is what I asked.
Oh, yes.
Okay, so let's color code this. Start with a color, start at the battery, and you just keep coloring until you hit a resistor. I'm actually going to erase mine and then color it back because my markers are getting kind of muddy. Stop. I have to stop when I get to a resistor because the idea is that the color is showing an equipotential line. Potential is joules per coulomb, energy per coulomb. So when I hit a resistor, the resistor kind of sucks some energy out and uses it to make light or sound or whatever. And so the potential is going to drop. So along here, the potential is the same. If it drops, it's not going to be the same anymore. I have to stop using that color. Yes?
What color do I color the resistor?
Don't color the resistor at all. Good question, actually. It's never clear. I should point that out more often. Okay? So I'm going to drop to a different voltage after the resistor. When I get there, I use a different color. And again, I keep going until I hit another resistor. And you have to color anything that's touching that same wire, all going to be the same voltage until hitting a resistor.
Oh,
Oh,
Out the picture again. How far over did this go?
I don't have like arms for this. I would go like this, but it's a table.
Yeah,
So the bottom one, since they're all touching, that's the last color.
that's the last color, that's right. So the last color is all of this, because it's all one piece of wire.
Is there Malaysia?
There we go. And then we're done. Oops.
And then the sister,
Once this thing is color-coded, it just helps us see where things are parallel. Remember that parallel things have the same voltage drop. In the color coding system, that means they all start on the same color and end on the same color. Does anybody see any pairs of resistors that are parallel? Brittany?
So, the 2/8.
The 2/8, exactly. They start on blue and on green. Start on blue and on green. Okay, so I know those are parallel. What I can do is find two resistors that are either parallel to each other or in series with each other. And then I'm going to combine those two resistors.
Oh, I get it.
And then
You get it? Yeah. I'm going to take those 2 8s and I'm just going to smush them into one resistor.
Make the 16.
Yeah, and then
Not 16.
No,
Because
it'd
they're
be
parallel.
2 8s, it'd be 4.
Yes, I have to do the fraction thing,
Oh.
right? So, in this case, I don't call this total resistance because it's not for the whole circuit. We just call it equivalent resistance because what we're finding is equivalent to the two resistors. It's like one. Anyway, so I get 1 8 plus 1 8, which is what?
2 4s.
2 8.
2 8s.
Just choose one.
So.
Just kidding.
So these two 8 ohm resistors are equivalent to one 4 ohm resistor. That just means I could yank out those two and replace them with one 4 ohm resistor. The way that I typically do this, and it's just a personal thing how I do this, I circle them and then in the middle of that like write what they'd be together, like that. It's like replacing them. You could also just redraw the whole thing. This is what actually happens on your homework. Is once I've replaced one resistor, they redraw the whole thing with that section replaced by one resistor of the equivalent resistance.
and then you add.
So in actuality, it's a series resistor, or it's a series.
Now it's a series, yeah.
Alright.
And what do we do with series?
Yeah,
That's right, just add them.
7 down.
So that is why the resistance was 7, just like Albert said. Nice job, Albert. Okay. Sometimes it's going to go the other way. You'll start with something where you have to put the series together, and then you end up with something in parallel. That might look like, sorry, it's going to be so small. Oh, how about over here? I'm running out of room. Okay, for instance, these two are a series because I can trace a line from one resistor to the other and I don't have any choices. No other path, one path. So I would put those together and then that new thing is parallel to this. So then I'd use the fraction to find the total resistance of those two. Okay. Now we're only doing, these are 3 resistor circuits. We can do as many resistors as we want. Yes?
What are examples that those circuits are used?
Oh, anything. Well, for example, remember when we were talking about overload last week? And we were just kept adding things on, and we said there was a circuit breaker, or before circuit breakers we had fuses. This could be a fuse, and then this would be like your wiring in your living room or whatever. It would be like that. Also, shortcut. Notice, whenever you have 2 resistors that are the same,
You just cut it in half.
yeah, in parallel, you just end up with it cut in half. So these are both 8, it turns out being 4. Does that make sense?
Yeah.
That's always true. That's always going to happen. Okay? So that's a little shortcut. I try to have those whenever possible as well. Yeah. Does anybody have any questions about how we got 7 over here, though? Again, tomorrow, this is the first step to finding all the currents and voltage drops of every resistor, solving the circuit. I'm going to do that tomorrow, though. Yes, one.
You draw this one out after you did like the series thing right there, please.
This one?
Yeah.
Okay. Actually, let's give it some numbers. How about,
Put in the back
geez, how many? We can do that 10, and this can be,
You should make them both 5.
how about like that?
5.
Yes, the answer is 5, because when I put these together, that's 10, so it'll look like, sorry, this is so sloppy, like super sloppy. and then those are in parallel, so it ends up being 5.
Oh, I get it.
Yeah? Okay. Good thing you asked. That helps somebody else out. Yeah. Any other questions?
Yeah, thanks, Mom.
Another one. Yes. Good questions from you.
So say there's a 1 right under it, would it just look like, right under
one-
the 10?
Like here?
Yeah. Would it just,
Would it be the same if you,
Yeah,
like whichever method
And,
you
like,
took, first
do like
parallel
this?
and then series?
yeah, would it
Or-
would be the same? Would it look the same at the, after you like combine
You solve it
them?
as a series and then you do the.
Well, what I could do is I could combine these as a series as well.
Yeah.
Let's make this
5.
5. So this would be 15 and 10. So this wouldn't be 5 anymore. It'd be something else.
Could you do parallels and then series?
Yeah, that was this one. Parallels and then a series.
Oh,
Yeah.
It's at 6. It's 6.
Is it?
Yeah.
Oh, it is. You're right. Yeah. And actually, there's one on your homework like that. Any other
Wait,
questions?
Michelle, draw like the final picture though.
Okay.
So like,
Well, the final picture from this would be,
Would be that, would it?
it would be this. Just one resistor. From here. So like these get smushed together into that one. These get smushed together into that one. Now those are parallel. I smush them together and I get a 6.
oh,
Okay. Any other questions? Okay then. Homework. Right now you only need to do the front. Okay. Again, we're going to do the back tomorrow. But if you are bored and you want to go ahead and try the back on your own, go ahead.